All right. Now, AMI is it's similar to your snapshot, but it keeps a whole machine image copy. So, for example, let's say you launch up an AWS instance, and you have installed 5 different softwares in it. You have installed your whole application in it, and now you want to create a copy of it. Not copy. Now you want to save it so that you can launch multiple instances. So what you do is you have, let's say, an EC2 instance. From an EC2 instance, you create an image. So you create an AMI. Using this AMI, you can launch multiple EC2 instances as you wish, right? So AMI acts as a copy of your instance. Now, in this instance, you can attach multiple softwares. You can have, let's say, you're going to install multiple things. On top of that, you've got Docker. On top of that, you've got your applications. Yeah, you've got your networking. So everything that once you have created this, you can store it as an AMI here. And then once you launch your different instances from here, so you will have the same EC2 created. So, all right. So AMI is the Amazon machine image. AMI is a customization of an EC2 instance. You add your own software, configuration, operating systems, and monitoring. AMI will offer a faster boot and configuration time because all your software is pre-packaged. You don't need to deploy everything again. So everything is now pre-packaged, and then you get the same machine which you stopped or which you terminated using your AMI. AMIs are built for a specific region. They can be copied across the regions. You can launch an EC2 instances from, so there are multiple sorts of AMIs. So either you can have a public AMI, AWS provided. AWS has got a marketplace from where you can get predefined AMIs. For example, if you are looking for if you're looking for an EC2 instance which already has got WordPress installed, so there are different vendors which will provide. So if you're looking for an EC2 instance which already has, let's say, a Postgres setup, which already has WordPress setup, which already has Apache setup. So there are multiple predefined AMIs which are provided by different vendors in AWS Marketplace. I think this is the one. You can also create your own AMIs. You may can maintain them yourself. Or a public AMI is what AWS provides. So when you're launching a Linux instance using Amazon Linux or Red Hat Linux, so there is a public AMI which is AWS provided. Now AMI process from an instance, you start an EC2 instance and customize it. You can stop the instance for data integrity. You can build an AMI using your EBS snapshots, and you can launch an instance from other AMIs. So let's say you got an instance in US East 1A. You can create an AMI here using this custom AMI, so you can launch it into another instance. So similar thing that you can do in your EBS, what we saw. So if you had an EBS, similarly, you create a snapshot. And from snapshot, you create another EBS, right? So same thing you can do with an AMI. You can create multiple instances and EBSs. EC2 instance store. So EBS volumes, they are network drives with good limited performance. So instance store, but is something where if you need a high performance hardware disk, you need to use instance store. So instance stores are basically used for your, let's say, your root volume, your boot up. So that's a better IO performance. They don't use EBS for just booting up your Linux box because that will be very slow. So that's where your instance volumes are used. And instance store loses their storage if they're stopped. They're good for buffer, cache, scratch data, or temporary content. There's a risk of loss of data if the hardware fails, and backup and replication are the customer's responsibility for an instance store. Now, these are some of the examples of instance store. So you've got the different instance sizes. So depending on which instance size that you are using, so you've got different read IOPS. So IOPS is your input output. Uh, I think PS consists of performance something and scalability. So you've got different sort of instance sizes here, and you've got the read and write IOPS. EBS, there are different sort of volume types. So you've got GP2 volume, which is a general purpose. You've got IO volumes for the high performance. You've got ST1 and SC1, which are low cost HDD volumes, defined for different sort of use cases for frequently accessed or less frequently accessed workloads. Some more types. So EBS volumes are characterized in size. Yeah. Encryption. So for people who do not understand encryption, so it's encryption is where you encrypt your data both at rest and in transit. EBS is your data at rest. So if your hard drive is encrypted, even on your Windows laptops and your MacBooks, you will see that it gives you an option to encrypt the drives. That means if anybody is able to detach the drive from your computer and attach it somewhere else, they'll not be able to read the data. So it's a key protected data. So EBS, you can create an encrypted EBS volume. So that means the data at rest is encrypted inside the volume. All the data in transit, so which is data in flight, moving between the instances, moving across the network, everything is all encrypted. So all the snapshots are encrypted. All the volumes created from the snapshots are encrypted. Now, encryption is it's extremely important that all the data that you preserve in the cloud is encrypted, and there's a very standard policy across all the different organizations. They do. It's a general practice to put all the data as encrypted, both at rest and in transit. So encryption and decryption, all you need to do is just select a button. You don't need to provide anything. Apart from, there are multiple sort of keys which support encryption and decryption. So you have the client based keys, you can have server based keys, but you don't really have to actively do anything apart from just selecting a few buttons and just putting in a key password either manually or ask AWS to use their own keys. Encryption has very minimal impact on latency. The encryption leverage keys from EBS encryption leverages the keys from KMS, which is the key management service. Copying an unencrypted snapshot always allows encryption, and snapshots of the encrypted volumes are encrypted. I think we saw that here. So encryption is very, very important. It does come up in a few interviews. What do you mean by encryption? What do you mean by encryption at rest, encryption at transit? How can you encrypt an EBS volume? Yeah, so I think we spoke about that. So encrypting an unencrypted EBS volume. So how do you do that? So you create an EBS snapshot, you encrypt the snapshot, and then you create a new EBS volume from the snapshot. So this is how if you have an unencrypted EBS volume, this is how you can actually encrypt it. Now, this is one of the last topics of this presentation, which is your elastic file system. So EBS and EFS both are similar, but they are different. So an EFS is a managed network file system that can be mounted on many EC2s. So if you remember, EBS can be mounted on only one EC2, but there's something called as EFS file system. It can be mounted on multiple EC2s. EFS works with EC2 instance in multiple availability zones. They're highly available, scalable, but they're expensive, pay per use. So similar to EBS. So if you have an EBS, it can attach to only a specific instance. So if you have EBS here, they can only be attached to one instance. But if you have an EFS here, you can have it's like a shareable drive across all the different multiple instances. So nothing too complicated. So EFS, The use case is content management. So if web serving, data sharing, WordPress. So some applications, you can have multiple servers connecting to a single hard drive. So that is EFS. It uses a specific protocol. It uses security group to control access to EFS. We had a look at the security group. We'll have a look more in the demo. Compatible with Linux-based EMIs, encryption at rest using KMS. All right. So I think so. This is the comparison between EBS and EFS. So I think EBS attaches to one drive, and EFS EBS snapshot is here. You can create a snapshot out of these.